Okay, so this is Monday, the 8th of August at lunchtime. So the transit from Sciacca to Pantelleria is about 5 hours, and that should happen overnight. The idea is that then we'll start geophysical acquisition as we move from the coastline towards Pantelleria. So we'll start with multi-beam and chirp. And then as we approach the coring sites here, we'll start acquiring sparkler data, so high resolution seismic over the coring sites, and that's going to tell us what's underneath the seafloor. And they should help us unraveling the record of high energy eruptions from Pantelleria. The reason why we want to study them, and in particular we want to study the effect that they have on the seafloor, is to be able to assess what we call geohazards. So geohazards are actually natural geological processes that might pose risks or hazards to human life, infrastructures on the seafloor, and even marine habitats. So we basically want to reconstruct how these eruptions affected the seafloor around the island, if they created erosion, for example, if they were large enough to create tsunamis, and how also how they affected the fauna on the seafloor.
Another important point is that quaternary anorogenic volcanism is associated to this rift process. 72% of the volcanic edifice is below sea level. It is common that volcanic islands represent just the very tip of the volcanic edifice, which is common, which can be huge, much huger than the emerged part. This means that most part of the history, the eruptive history of the volcano is unknown. And what we can study from the subaerial part is limited often to the recent most activity. This is exactly the case of Pantelleria, where the green tuff deposits covered most of the island. Moreover, there is evidence that the recent most activity that occurred in 1891, so very recently, was from a submarine vent. Some studies carried out in the last 10 years showed which could be the presumed eruptive vent. And this teaches us that we have, of course, to enlarge the knowledge of the volcanic edifices to submarine portions, in order also to have a better knowledge of how volcanoes can behave in the future, so what we can expect from possible further activity.
Luckily, in the last 24 hours, we started getting some geophysical data, which are basically images of the seafloor, and also acoustic data of the different layers that are found underneath the seafloor. And those can tell us about past volcanic eruptions and how they spread out in the basins around Pantelleria. And today we managed to acquire some sediment cores. And these cores will actually be used to look at the different records of these volcaniclastic events, of these eruptions in the seafloor. This is actually one section from one of the cores that we collected from the seafloor today. The full core is 5.5 meters long. This is really just the top 46 centimeters. Actually, this is the sediment that's deposited at the seafloor, and then we have, for most of these cores, what we've seen just by cutting it into shorter sections is quite a lot of mud that we would expect in this kind of environment, but we also found some volcaniclastic sands. So we already know that we have targeted the right spots to get information about past eruptions. So whenever we start now the multi-beam and the chirp, that's the SOL1, start of line 1. So the idea is that by assessing how these eruptions spread on the seafloor, how much material they moved, then we'll be able to assess if they can create, for example, tsunamis, or which effects they will have on the seafloor. So really what we need to know, because it's very hard to witness these events normally, they're far apart. Whenever they happen, they're so catastrophic that it's hard to study them in the field. knowing what happened in the past is really going to help us to forecast and create models about what would happen in the case of future volcanic eruptions near the sea.